When was the last time you washed a lettuce before eating it? Most of us wash vegetables to remove dirt or pesticide residues. But have you ever thought about something that cannot be seen? Microplastic. If I told you this bowl contained tiny plastic particles, would you still eat it? The surprising part is that microplastics don't just end up in water, they can also enter the vegetable we eat every day. This isn't science fiction. It's becoming a real concern for agriculture, food safety, and public health. Good day, doctor. My name is Heng Chai Shen, and today I'd like to share why I chose Camera Highland as my case study and how biotechnology could become part of the solution to one of today's growing environmental challenges. Camera Highland supplies approximately 60 to 70% of Malaysia's leafy vegetables. Every day, thousands of families depend on vegetable produce here. However, intensive farming also relies heavily on plastic mulch, irrigation system, greenhouse materials, and fertilizer. Over time, this plastic breaks down into tiny fragments called microplastic, which accumulate in agricultural soil. What makes this problem worrying is that these particles do not simply stay in the soil. Studies show that lettuce root can absorb microplastic through tiny openings formed during root development. Once inside the plant, water moving through the xylem and transports some of these particles upward into the leaf. Inside the cells, microplastic increase oxidative stress by producing excessive reactive oxygen species. This damages the proteins, lipid, and DNA, reduce chlorophyll, disrupt nutrient uptake, and ultimately lowers plant growth and nutritional quality. In other words, the health of the plant and potentially safety of our food can be affected. Fortunately, science also offers hope. One promising solution is a natural occurring of plastic degrading bacterium called Ideonella sacchaensis. This bacterium produces two remarkable enzymes known as peptase and amylase. Together, this enzyme break down PET plastic into much smaller molecules, including terephthalic acid and ethylene glycol, which microorganisms can further utilize. If applied carefully in contaminated agriculture environment, this biotechnology has the potential to reduce PET plastic pollution before it causes even greater environmental damage. However, biotechnology is not a miracle solution. Ideonella sacchaensis mainly degrades PET plastic, while many agricultural plastics are made from polyethylene or PE. Its effectiveness can also be influenced by environmental conditions, and any field application must undergo proper biosafety assessment. This reminds us that scientific innovation should always be balanced with environmental responsibility and careful regulation. Before starting this project, I believe microplastic pollution was mainly an ocean problem. I never imagined that tiny plastic particles could also enter agricultural soils and into the vegetable on our dining table. As someone living in Malaysia, this research made me realize that protecting food security begins long before food reach our plates. It begins in the soil where our crops grow. Personally, I believe biotechnology should help us repair the environmental damage we have already created, but it should never be an excuse to continue producing and using plastic irresponsibly. Scientists, farmers, industry, governments, and consumers all share the responsibility of protecting our food system. Sustainable agriculture is not only about producing more food, it is about producing food that is safe for both people and our planet. The next time we enjoy a fresh salad, perhaps the question isn't whether it looks healthy. The real question is, have we done enough to keep it truly safe? Thank you.